Welcome to the Meltzone podcast from Monday, March 9th, 2020. This is episode 31, and I'm Tom.
And I'm Stefan. And on today's episode, we talk a little bit about Tom's recent resin testing consistency results, why his resin prints were, breaking at different levels, and if that might have something to do with the way he cured them, or even the color that the resins were. I got a big package from E3D. I finally got a Toolchanger that I hope that I can use in the future for a couple of multi-material or even multi-tool prints. So, stay tuned for that. We reached a milestone, and today we have just reached the Schnapszahl subscriber count of 7,777.7 subscribers. So really cool. On other recent, not really news, but on the current situation, we talk about the recent trips to Murph and also Malta Maker Fair, if we are going to make it, and if I might have to skip Murph for a couple of personal reasons. And I'm really sad that I probably need to make that decision, but more about that later.
On the questions section today, are we Prusa shows? It's like a recurring topic. The issues or the supposed issues that have been found with the Prusa Minis bed wiring and how everything is attached together. A few things about lightweight PLA that really seems to be tickling you guys' fancies. Can it be used as a rubber damper? And can it be used for lost material casting, for doing investment casting of metals using 3D printed parts as a positive that then gets burnt out? Technical question: why are we not seeing linear motors used on 3D printers? I tried to explain what a linear motor is and why it's perhaps not as good of a fit as a regular stepper motor for a 3D printer. And lastly, we found PLA for reasonable prices, and Stefan can finally go ahead and make some filament from virgin material. Stefan, have you seen my latest experiments and non-results that I got?
Yes, I did. I really did. It's interesting. It's really interesting because you did these tests, I did these tests. The results were, I think, not perfectly the same. But yeah, you found some inconsistencies, not actually with your setup, but with like the way the material reacted and the way the material you post-processed.
Let's be fair. My setup isn't perfect, and I've mentioned that in the video. I know, like, me physically pulling on a thing is not going to be 100% accurate. It's not going to be as good as yours, where you have a machine just consistently pulling on it. Yeah. But I know how much of a variation I have, and it's not on that scale. Yeah.
So you're actually talking about your resin tests.
Yes. We should maybe clarify that. So the resin test, I don't know. Have you seen anything like that where resin just isn't consistent?
At least
on that scale.
At least for the tests that I did, I was really surprised how consistent my results were. And perfect. To be honest, when I did the test, I think one set of samples I forgot under the UV light, and a couple of other ones I just processed for, I think, half an hour or something like that. So the curing setup for me was not the most consistent one. So I was really surprised to see what issues you had, even though you were using the CW1, so the curing station that ships with the Prusa.
The interesting thing is Prusa actually recommend, hey, we've set this machine to 3 minutes of curing.
This is okay.
And it's, I mean, I don't know how much LED power they have in there, but it's not a lot. It is not like 150 watts of UV LED that's burning this thing down. It's more like, I think, 20-ish, if anything. And that already seemed low to me. So I've already cranked it up to 5, which is still, compared to like 30 minutes, still not a lot.
Yeah.
So but you thinking it's just that it's not cured enough?
It's hard. If I see a translucent...
Some of the resins were very soft still.
Yeah. If I see a translucent 3D print, it's kind of hard for me to imagine how the UV light will penetrate through the whole part. But you also had kind of the same variance with transparent parts. And this was...
I tested the Ilgu ABS like transparent resin for the most part, because it was a bit more consistent and a bit more in line with what I would be expecting already. But I don't know if the UV light actually penetrates into the optically transparent parts, because if it's, it's still a red tint.
Yeah.
So I assume that acts as a very thin notch filter that just leaves through or allows red light to pass, and everything else is blocked. And red light is pretty much on the opposite end of the spectrum as UV light, or near UV.
Yeah.
So I don't think there's much of a difference with transparent versus non-transparent, at least when it's a red resin like that. Still, does a resin part even cure on the inside at all? Is that something that's expected, or is it just a norm that it's, hey, you print it in the machine and your layer exposure time is all the exposure you're ever going to get?
It would be interesting to know that. So it maybe would be interesting to cut up a part, and as you also do it, to figure out if you, for example, hardened a metal part all the way, you do incremental hardness tests all the way from the side of the part to the center. So the thing is, for example, the Formlabs printers, their preparation software tells you, okay, if you have a really beefy and thick part, hey, we think you might have issues with curing, maybe hollow the part out or do something different to not have this accumulation of, wall thickness. So there is probably...
And that is specifically for curing and not for, hey, it might warp or something, where it might just be too much material that you're using up.
I'm not 100% sure, because I have basically not worked with the Formlabs printer at work yet, but a colleague of mine told me that with another part where we also had a similar issue. So I still think it is a problem, and the resin will absorb some of the UV light when it's going through the part. 3 minutes of curing time is also something that I find just really, really little. The curing station from Formlabs, they usually run it for, I think, 10 to 15 minutes. And it's really interesting because for all of the resins that Formlabs is selling, they are giving you the curing times and the curing temperatures that are recommended.
Right.
And also for the materials, they give you the properties of the material in its uncured state and in its fully cured state. And those properties can vary quite a bit. So what could happen in the end, if your part is too thick and the UV light doesn't penetrate all the way, so it doesn't cure the inside of the part, that you have kind of a gradient of properties that is fully cured on the outside and gets weaker and weaker, to the middle. Yeah. The thing is...
an uncured part just naturally is always going to be weaker and softer. It's in no circumstances an uncured part going to be stronger.
It is more ductile, and this might be even make a part stronger because it's more flexible. In rare cases,
depending on the part geometry, yes.
Depending on the part geometry, I think there's a if you have a resin that gets really, really brittle when it's fully cured, this might be weaker for a certain application than an uncured part that is still softer.
Right.
But I think that's not really by design. So when I'm thinking, you just said something about the color of your resin, that yours was red. The one that I was using, the blue resin from Siraya Tech.
Yeah, Siraya Tech. That's the one. After you did the video,
Yeah.
that's the one that everyone's talking about.
Yeah.
Saying, "Hey, Tom, test this. I've heard this is really strong."
Yeah.
Obviously, you've tested it.
Well, it is blue material, so maybe
Okay.
the filtering of the light spectrum is in a way that it lets the UV light penetrate deeper into the part, and that was helping me for consistency. So what I wanted to say with that, it might be really interesting to do a comparison of different resin colors and how their properties turn out.
Yeah, from the same brand, same line of resins, just do different colors. Because, I mean, it does make sense. Blue is very close to UV. And the UV light we use for curing, what is it, 405-ish? Yeah. I mean, technically, that's just barely UV. That's more like a very deep blue. So yeah, if it's blue, it makes sense. Clear probably has the best strength then, or the best curing properties.
Curing properties, maybe the best consistency. I don't know. It might be really interesting.
So much to dive into.
To dig deeper into that. But also on that remark, I don't know if you can see it in the background. I have had for ages a couple of different colored samples of PLA filament right here that I want to test for strength to see if the pigment that is used for coloring the PLA has a different on properties of the final part.
What was it? Yellow filament is like weaker or something?
I think
that's something that often comes up.
The pink one was really was it weak or was really impact resistant? I don't know. So there was one paper. We talked about that, I think, in another podcast. And they also did that test and they found quite a big variance between colors. But
what my mind's jumping to right now is because, I mean, it's not just a dye or something, it's actually a pigment. Pigments are basically small particles that you dump into your filament. It's depending on what sort of a pigment you put in, it might start like crystallization, what's it called, granules. Like it just give the filament a starting point to crystallize at that point. And as we all know, crystallized filament, it does behave, or crystallized PLA does behave quite a bit differently than non-crystallized or amorphous material. So that could actually make quite a big difference there.
I asked around to a couple of filament manufacturers and nobody had a real answer for me. So nobody really tested it. So they usually they only use injection molded samples for getting the material data sheet. So yeah, this is a project I really wanted to do for quite a while, just to see how the results are. I know from injection molding, just a guy that I know that runs a injection molding shop, he told me that, for example, if they use blue pigment in their for PE injection molding, they have way more shrinking than if they are using other colors, which is really interesting. So he said that there's a really big correlation between, well, in this case, shrinking of the material to the pigment that you're using. So there might be something in that direction. It is not directly connected to the reason why resin might behave differently, because maybe it's just light absorption.
Maybe there is,
But it might be an interesting topic just to research and see if there's really a change.
To really deep dive, You know what else is a deep dive? Your Toolchanger. Holy crap, you've got yourself into something there.
Yeah, I finally received the Toolchanger. So I was kind of crying out in my lightweight PLA video that I really want to print a wing with different ratios of foaming on the inside and on the outside. And just Sanjay reached out to me and asked me, hey, do you want to have a Toolchanger for that application? And since I don't have a proper multi-material or multi-nozzle 3D printer, I was really just begging to have one because it is mechanically a really, really nice machine.
Yeah.
But it's a project, I
regulated.
guess.
Second?
I think it's quite a project to put it together and to
Yes.
calibrate it and things like that.
Yes. I mean, they've offered me a Toolchanger too. A while ago when it was still like in beta, or like was the beta 100?
Yeah, beta
First 100
300
machines or something. 300, yeah. They were like, hey, do you want to try one out? And it was always like, I would love to, but it's gonna take up so much of my time. I don't think I can go through it. So it's gonna be interesting to see what you think and how much effort you have to go through.
Yeah.
So you got you basically have everything for that, right? You have 4 tool heads, I assume, the whole kinematics platform, do it, everything you need to get it running.
I hope. I have a big box next to me, and hopefully there's gonna be everything in there that I need to assemble. So yeah,
Nice.
Sanjay told me that there's gonna be 4 Hermia extruders that he kind of dug out of a pile of rejected ones from quality control. So he said, okay, just pay attention if something's not working. That might the reason for that might be that this was just a rejected one from somewhere, which is totally fine for me. I really appreciate the support from that side, because I think it's a gorgeous machine, and I have quite a couple of ideas that I want to do with such a machine that does not only give you the opportunity to have multi-material 3D printing, but you can really have different tool heads for different applications and things like that.
The question about that is always, what sort of tool do you prepare your toolpaths with? Like, if you have, of course, the idea with the Toolchanger is not just to have 3 different FDM heads, FFF, whatever, extruder heads, but also to have like a milling head or a camera or an inkjet printer or whatever else on there. I guess there's still not much going on there.
Yeah. So yeah, looking forward to maybe an integration in Fusion 360 that might enable something like that. Passio isn't happening anymore, so I think we won't see any integration from that side.
Wait, did they cancel that?
It's currently not being developed as much as I know.
Okay.
So
because I've actually not heard anything about the project since. I think they had a few updates or something since I took a first look at it.
But there hasn't been one for, I think, almost a year. So I don't know how much development is really going on in that direction. So it's kind of sad, but maybe they noticed that this is quite an undertaking to get a new slice onto the market.
I mean, they jumped at it with the right force, with the right what's it called, determination, I guess. They had a whole team of people there. I don't know, but I guess there's no official, hey, this project is now dead confirmation or anything yet.
Let me check, but I would not know. So I have a couple of things planned that I think I can do without the need of a specific slicer for that. So one thing is it's called ZHooks. So you kind of leave voids into your part, and then you fill those voids in an additional step, either with a separate nozzle, or you could even use the same nozzle to have hooks into your part that kind of glue the layers together.
Ooh.
Or you could even put something like a 2-part epoxy syringe on one of the tool heads to fill those voids. Something in that direction, I think, would be just interesting to play around with.
Yeah, maybe just hack together some manual G code, or use your Python coding skills and do a post processor.
Yep.
Nice. Where are my tabs? There are my tabs at. Okay. I just tried to find some info on Passio. The last beta release that they're calling Big Beta was July 23rd, 2019.
Yeah.
And there was 063 beta 3. Fade over to beta. Is there anything more recent than that? Beta 4. So there's been a release since.
Yeah.
I would guess there's still development happening.
Okay.
It's just no official cancellation. So there might be something big coming, or it might just be faded out. I don't know.
We'll see. We'll see. Yeah, I guess we have also reached a milestone, a Schnapszahl milestone for the podcast.
Yeah, let's hope that's not the cue for us to start tapering out and start shutting down. No, we are, as we speak, at 7,777.7 subscribers. Maybe we'll get the 0.3 subscriber to get us to one above that Schnapszahl by the end of this podcast. But yeah, nice. I mean, I did bring a few subscribers along with the channel because this used to be like what was it?
Tom's live. Tom.
Oh yeah, live channel, right?
Yeah.
Right. I pulled a sneaky on you and actually carried over those subscribers, thinking like, if you're interested in live stuff, then you're probably interested in something that is essentially a live recording of a conversation we're having. But yeah, we've gained quite a few subscribers on YouTube, and we're getting pretty solid, listen hours on the other platforms as well. So thank you all for watching and supporting the podcast just by listening to it.
Yeah, thank you so much.
Yeah, 10K. I mean, we're gonna get the YouTube. No, no, hold on. You don't get one for 10K.
That's happening quite a bit later.
I wish I was 10K. No. We can maybe print one for 10K.
Yeah, or you can shape one out on your shaper.
Oh yeah, not out of aluminum. Not out of this aluminum. I've gotten some feedback from the shaper team.
Okay.
I will retry. I'll try a different I do still have some material from a heated bed, just a milled flat aluminum, which is I think a cast aluminum and not a rolled and formed that way. So that's a bit more brittle when you cut it. It's not as ductile and as goopy.
Yeah.
Which I know that the material that I tried to cut into is like the worst to cut.
Yeah.
But still, if you have to reduce your feed rates that much, just to not get it to like work against you that much. In wood, it's okay because you have some friction. On aluminum, it's like it's very difficult to get some traction there, so you have to push against the machine, and it's just it's fantastic for wood. It's a really nice tool for cutting into wood, but I don't think I mean, even though it might be possible to do it cleanly, I don't think I actually want to cut aluminum with that.
Yeah. But I also had the same experience when I worked with just flat sheets of aluminum on my CNC router, that there is a huge difference on the type of alloy that you're using. So I specifically bought a machinable
US part?
Yeah.
Machinable.
Alloy, and it's way better and way easier to work with than just the standard hardware store aluminum that you're usually getting.
Yeah, it is quite a bit more expensive if you get the actual machinable alloys.
Yeah,
I think it may be about twice as much at times.
Yeah,
but yeah, it does make a huge difference. Still, I mean, on a CNC, on an automated tool, I have no issues having a cut job run for 45 minutes.
Yeah.
But if you're actually dragging the tool and if you have to position it for 45 minutes, like that gets that wears you down. That physically wears you down.
Yeah.
So I think the plate that I tried to make was actually for this thing, and we'll get to a comment about why we don't add more videos and descriptive imagery into our podcast. But for this thing, this is going to be at some point in a different configuration. This is going to be the next Halloween testing jig. I think I'm just going to route it out of plywood.
Yeah.
Maybe I'll get some nice hardwood plywood in a decent thickness, and that should be enough to take the 5,000 newtons from this load cell that's going to introduce.
Mine is also totally made from wood. The reason why I build all of my machines out of wood, because it is an easy material for me to work with if you don't have specialized tools, if you don't have a proper a proper lathe, a proper router, and things like that.
Yeah.
Mill.
And in fact, behind me, sorry about all you audio listeners, but behind me we've got the Mendel 9000, which is also built from mostly plywood.
Yeah.
And it is perfectly square, perfectly flat. It's been a real joy to work on, even though it's not been that much of a joy to work on because it's way overbuilt. But it is a very appropriate material, even OSB. I mean, it's an engineered material that is meant to be a permanent building material, right?
Yeah, and it has the advantage that it absorbs more of the vibrations than normal metal does. It's
true.
And yeah, this is the I've been thinking for quite a while that I want to revisit my wooden CNC router project and really to start from the basics again and engineer a wooden CNC mill that is capable of machining steel.
I've actually run some like napkin math on the entire thing because I've thought about doing the exact same thing, and just for like I think the goal was like a 1x1 meter or something, or 1x1.5, or so like a traditional portal router style thing. And if you just build like a beam out of plywood, if you have like the 16 millimeter plywood and just build a beam that's, I don't know, 10 by 15 centimeters or something, that thing is going to be so freaking rigid. You bolt some MGN12 to that, and you've got yourself a perfectly rigid CNC setup, essentially.
I actually wouldn't want to build it router style, so like 1 meter by 1 meter. I really would like to have a stiff setup where you only have like 30 centimeters by 30 centimeters by 30 centimeters, because the problem I'm always facing with my big style half meter by half meter CNC routers is that they are too wobbly due to the gantry, due to the due to the portal, because that flexes, this takes a lot of torsion and things like that. I would really like to build a wooden CNC mill in a way like a Bridgeport mill, for example, looks like, and just something like that. Maybe
that would be interesting.
Maybe
so you're gonna have a table, an XY table on the bottom, and then a Z axis up top.
Yeah.
Okay.
I would really like to do that,
or just have a knee on the Z.
Yeah, something like that. I think it's totally doable, and it might give you really nice results. And if you're not using a bunch of cutting fluid, I think it's probably good for machining steel and stuff like that if you do it properly. And you don't need specific tools to do it. Maybe even just fill half of it with concrete in the end, just because concrete.
Totally makes sense. Adds a bunch of weight. I mean, for vibrations and stuff, wood is already better. And you can always fill it either concrete or sand if you just want the vibration properties and get some extra weight.
Yeah. So
wood really is an underrated material, I think.
Definitely.
I think it's like, oh yeah, it's like all machined aluminum and like, ooh, but use plywood painted and it's as good as anything.
Yeah.
And I've actually looked at like plywood prices in the US. Who was I? Yeah, I for the shaper, because like the obvious use case for the shaper is you put a bunch of tape over a sheet of plywood and it's like, there you go, you route out your furniture or whatever. And plywood in the US is incredibly cheap.
Yeah,
it's like half the price that it is here. Because it's used in construction, it's used for building houses.
Yeah,
we don't typically build houses out of plywood here. We do use some, but not as much as the US. So yeah, but even still, it's a very cheap material compared to buying a sheet of aluminum.
Yeah.
Nice.
So we'll see. Maybe I need to get back to you at some point and use the shaper to route out a couple of big side pieces for that thing.
Making a CNC with a handheld CNC, yeah.
Something like that. Yeah. Let's see.
CNC project. Have you seen Ivan Mirinda's latest video?
I haven't watched it yet. I have watched the previous ones, but I've seen a couple of videos on Instagram, I think yesterday, where he was routing out a gear, and my jaw just dropped. Looked really nice.
So basically he built, I mean, of course he's doing 3D printed stuff. So he built let's call it it's a mostly printed, CNC, though, well, whatever. It's a CNC router that uses large chunks of 3D printed parts. So that plus easily available 30 by 30 millimeter aluminum tubing, and it seems to be doing incredibly well for like being aluminum plus plastic. And it looks really simple to build. Like, you can tell he put a ton of effort into designing the parts and into making everything work together. But it's just a really simple looking machine.
Yeah, and I think he actually released all of the CAD files.
Maybe to his patrons, but I think the files are only gonna be available once he's cleaned them up.
Okay, yeah.
Which hopefully that's not going to be the same thing as, when everybody else says, "Oh, I'm going to release them when I've cleaned them up," which means never. Yeah, but the plan is to release them.
Yeah. I'll put a link to the video in the description.
Yes.
For everyone who's interested.
Yes, and I think we'll actually skip this topic and move on to the next one. Murph, Maker Faire Malta, COVID-19.
So you're still planning to go to Malta and to Chicago, or Goshen. Sorry.
YOLO. Yes, I am planning on going to Maker Faire Malta, and then the week after that to Murph. I mean, Murph, I kind of can't miss.
Yeah. So yeah, it is hard at the moment, and especially if you're reading about already a lot of others canceling their trip to Murph. I just recently, I think yesterday, read that Gina is not going, and I am also tempted to stay at home due to the reason that I'll be getting married a week after Murph. And if I just
wouldn't risk that, to be
catch
honest,
something there, even though it's not Corona, I think it's probably really not unreasonable. What's the right word?
Inconsiderate
to be like the man on the wedding, the groom on the wedding that is shaking hands with everyone, and there is a chance that you have Corona. So I haven't decided yet totally, but maybe I just have to stay at home. I hope that maybe then I have the chance to go to the East Coast Red Bread Festival, because I was really looking forward to, but it's really hard at the moment.
Yeah, I mean, I don't blame you. I can't blame you. I'm still set on going. The idea, anyways, is that I'm the freelance dude working from my own office. I don't need to talk to people all day, and I'll definitely be staying at home a lot after I get back from both Murph and, I mean, once I get back from Maker Faire Malta, I've got a week to kind of develop symptoms. So I'm hoping if I'm gonna know if I'm sick or not by the time I head out to Murph.
Yeah.
And then of course after Murph, I'll stay home for a while.
Yeah.
Try not to shake too many hands here, and of course maybe even avoid fist bumps this year on Murph.
Well, elbow bumps
to do the foot thing.
Yeah. If it wasn't for me, if I wouldn't get married just the week after Murph, I would have definitely gone to Murph, because it is just a lot. Well, it is pushed a lot in the news lately, the problem all around Corona and things like that. So I'm a healthy person, not too old, not too young. I think it would probably be not that harmful, even though I would catch anything, but just due to the I mean, the thing is just, we as young people, or relatively, we still think ourselves or consider ourselves young.
we're not that young anymore. But for us, it's if we catch it, we're gonna survive, most likely.
Yeah.
Like, it's not gonna be comfortable probably, but it's not gonna kill us. But if you have contact with other folks that might be spreading it, or if you have elderly grandparents that you visit or something, then that's, again, I think inconsiderate would be the correct term for that. Like I said, I have the choice of quarantining myself.
Yeah.
Is that the, yeah. I can do that, and I will definitely do that, just because, like, why take chances? I don't have to talk to people all day. It's not going to be that different from what I'm doing anyways.
Yeah.
So yeah, I still do want to go to Murph. It's still solidly planned. So, I mean, if you're not going, I guess I'm going to have to cancel the Model 3 I had reserved for the trip.
It's too
I'm
expensive.
not going to rent it just for myself.
Well, you still could have fun with it.
But if it's just for me, like, I already drive an EV. I don't need to. I need that. I don't know what it's like.
Yeah. Well,
experiencing the autopilot would be nice, but just for one person, I think it's a bit overkill.
But you tried out the Citroen 208 at the weekend.
Close.
Peugeot. Damn
it. Same company, but the Peugeot E208. Yes, over the weekend I had it from Saturday to Monday. Brilliant little car.
Enjoyed it?
Very quirky, very, very French, I guess.
Okay.
But coming from a Leaf, it's just so much of a better car.
Okay. Why?
Why? What? How can you be a worse car than the Leaf? Okay, no. Anyways, the issues I have with the Leaf is it's essentially, it's a very old car that's been made to look a bit newer, and the E208 is a from the ground up new car essentially. So that is the electric powertrain. So it's got a bit less power than the Leaf when it comes to driving, but it's a bit lighter car too. It uses less power. I've done the same, 110, 120, 130, 140 kilometers an hour on the Autobahn and kind of compared, and it's a good bit more efficient. It does 100 kilowatt fast charging. The infotainment doesn't suck. Driving is a bit nicer. It's a bit smaller car. Mm-hmm. So the trunk is a bit smaller. Second row or rear seats are a bit more cramped, but not that much. What else? And it looks better too. But that's like, I could have lived with Leaf. But it's just the point that my point of, hey, I can't live with this with the Leaf was when it took me 6.5 hours to get home from Stuttgart from the Shaper workshop because of rapid gate and excessive consumption and driving into the concrete pillars on the Autobahn because the lane keep just failed or it didn't reactivate. That's a trip that you usually do in like 3 hours in a gas car. And like predictions for the 208 or my own napkin math is like, 4 hours with recharges.
Okay.
And 6.5 hours. I got home after midnight. I was planning to be home by like 10. And it's just not practical. It's for like, going to the supermarket or driving, in like the local area, or even if you have to recharge, like you can do that, but it's really anything that's like outside of your regular range is just not gonna happen.
What's the battery capacity compared to your Leaf?
So the Leaf is 40 kilowatt hours gross capacity, and the E208 and also the basically identical Corsa E, the Opel Vauxhall Corsa E, 50 kilowatt hours.
Okay.
And that's gross capacity, so net capacity is going to be a bit less.
Okay.
Really, though, capacity doesn't matter when you can recharge with 100 kilowatts.
Okay.
So you take a break for 15 minutes and you're back at 50%.
Cool. But
from zero.
Do the usual charging stations support 100 kilowatt fast charging?
Many, actually.
Okay.
Many. So obviously, like not every charging station supports 100 kilowatt DC fast charging. Many are just 50, which is fine for the Leaf. But if you use a route planner like a better route planner, .com, they will actually factor in charging times for you and will direct you to 100 kilowatt chargers, and there are plenty for the trips or for basically going anywhere.
Cool. It's just so unimaginable for me to just pump 100 kilowatts of power through such a thick or thin wire or cable.
It's 2 times 70 millimeters squared. What I read on the 150 kilowatt charger that I charged up yesterday. I think FastNet is maybe even a bit thicker. I don't know. FastNet does 350 kilowatts, though that is at 800 volts and not at 400.
Okay.
So that's like Taycan.
Okay.
Taycan. Porsche.
Cool.
Speed. So yeah, the only thing now is I have to get out of that lease contract with the Leaf. I'll probably have to buy the car and sell it to the Peugeot dealership, who has offered a reasonable buyback rate. But of course, what Nissan's going to charge me for buying that car back is going to be more than the car is worth.
That's
like
unfortunate.
They've got the high ground.
Yeah, but if you're not happy with the car for the next 3 years or something like that,
yeah, like another 3.5 years. It's just, I mean, for like daily commuting, short trip stuff, but overall, it's just not a practical car. I've not sold. The plan was to sell my 3 Series that I did the UK road trip with. But I still have that car. I still have that because I just don't think I'll be able to manage with the Leaf for doing a longer trip or something. And yes, I know I should be taking the train, but if it takes you 6 hours plus on the train to Stuttgart and then you're not even where you need to be, and you still have to take the taxi, that's also not too practical.
Yeah, I can imagine that. Yeah, well, I think it's good that you still want to stick to an EV after that experience that you had.
That's not up for discussion. Like I'm not buying another gas car or a diesel car.
Yeah, interesting. Well, maybe on the topic of thick cables and electricity.
Oh God, what a transition.
What a transition. Let's talk about the Prusa Mini. And somebody said that we are shills for Prusa and didn't talk about the current problems that the Prusa machines have. We talked about the encoder problem. And to be honest, last time I just didn't think about the other issue that came up with the Prusa that I also, saw on Twitter. So what Ottoman is saying that the Prusa supposedly has issues, or some are claiming that it is not the proper way to attach the cables of the heated bed with stainless steel bolts. Prusa has reacted to that. There is an article on the Prusa website that is talking about that issue, and it's also showing that it is not an issue, especially because the amperage of the small heated bed is not too high, and also the resistivity of the stainless steel bolt is totally sufficient for that application. So the thing that was happening, and also what I saw on Twitter, is that people posted shots of the cable shoes that are connected to the heated bed with a stainless steel bolt, and those cable shoes were connected, I think, probably the wrong way around. So they were not.
It looks like they should be on the pad up top. Yeah.
So they were not connected directly on the pad on top to the bed. So the electricity had to flow through the stainless steel bolt into the upper pad. I'm not 100% sure if it is supposed to look like that. I don't think it should, because it's better to directly clamp the cable shoe to the pad than relying on the stainless steel bolt. But even though, if this is happening, as I said, Prusa tested it out and it doesn't seem to be an issue. So the resistance is very low, so there shouldn't be any heat being produced at that location. And I'm not 100% sure, but I think my Mark III is also connected in a similar way, so that a bolt holds the cable shoes at the location where the connection is. So the pad is to the heated bed. And I still think it's a better solution than soldering the cables directly to the heated bed without a proper strain relief.
I guess the crimp connector, the cable shoe, is a bit better strain relief than having like the solder wick up into the cable. Now, when it comes to why we're not talking about this, it's for me at least, it's the same as with any other machine. I comment on issues and input I have with the machines that I actually own, and I don't have a Prusa Mini.
Yeah,
simple story. I don't think I've ever like commented on stuff that I saw on the internet on another machine. And until I have I have a review unit for the Mini, I would rather kind of make up my own mind on this and not speculate based on what other people are seeing.
Yeah,
I know both for good and bad. I mean, Prusa does have a track record of making good machines, I think, and so for the machines that I've tested from them are decent. But of course, that does reset with every new product they bring out. That built up trust that I have in them.
Yeah.
So,
well, me too. And they reacted to those claims and showed that it is not an issue. As I said, I don't know fully if it's supposed to look like that, but for everyone who's interested, can check out the Twitter posts and also the reaction from Prusa research.
For the blog. I mean, just generally having a screwed down crimp connector or connector like that is perfectly appropriate. Is done regularly in pretty much every home wiring job or any wiring job. You're gonna have a screw on a crimp connector like that. Usually the current isn't supposed to be flowing through the screw, yes, but that screw is so thick and the current path is so short, you're not going to get any significant heating. Plus, it's a heated bed, like it's supposed to get hot. Anyway, it shouldn't get hot at the connectors, but still, it's going to be fine. The one issue I would have with this sort of connector that I would be looking out for is if it does come loose over time. Yeah. Because typically those connectors, that style of connector is only pressing down on metal. So you either have you have copper and you have steel and you have metals and you tighten those and they stay put. You have your nominal torque for the screw and you clamp that down and it just that locks the screw in place. If you have something like F44, which is fiber plus resin, I don't know how that reacts under pressure. If it's like a plastic and just flows away and kind of loosens up that connection over time, that is something that I would need to research and would need to look into whether FR4 is actually good for or rated for that. I think it would be nice to see some sort of a spring-loaded element in that screw connection, like a spring washer or something along those lines, just to make sure that it does have some. It does retain some tension over time.
Okay. Do you know if for such applications usually are there copper screws or something like that have lower resistance?
No, usually
even though I don't say that a copper screw for that application would be good because it work hardens and it's
a very soft material.
Very soft material, yeah.
Usually the screw connection is not a functional part of an electrical connection. Usually you're just pressing, like we see on the image there, usually you're pressing your crimp connector, your flange on the
pad
directly onto your pad, onto your connector where the current flows back out. Usually you don't conduct electricity through a screw or through your fastening element.
And the resistance is probably proportional to the clamping pressure in that connection. The resistance between the cable shoe and the pad where the electricity needs to flow.
If you have them in direct contact, yeah.
Okay.
Yeah, though stuff like the crimp connectors and stuff are usually sized in a way where the connection itself is not the limiting factor for how much current you can push through it, simply because it's expected to make good enough contact to a point where your cable that you're actually crimping into that connector is the limiting factor.
Okay. Interesting.
So yeah, if it's only it's only going to be long term. In the short term, I don't think this is an issue. But yeah, I'll have to test for myself.
Yeah, I think as soon as, well, probably similarly to the Resin Prusa. What's the name? The SL1.
SL1.
I think they will be starting to send out review units as soon as they finished managing the backlog of pre-ordered units and also just figured out all of the issues they are still having.
Which, of course, is an interesting strategy. I mean, typically with like phones and computer hardware and stuff, you get review samples before the thing is even launched, including all the issues that you have. What was it? The 5600 XT launch, AMD's 5600 XT, where reviewers got like a new BIOS that increased performance by like 15% the day before the reviews were supposed to go live, and they had to redo all their testing. That's not fun, because at that point, like as a reviewer, you're doing the beta testing, and you're like expected to report back to the manufacturer if you run into any issues, and your issues are going to be fixed by the time you're done. And it's just, why am I doing the testing for you? On the other hand, what Prusa are doing is waiting with machines for review to be shipped out. That sentence isn't properly structured, I'm sorry. But with Prusa waiting for machines to be shipped out so long until they've basically made 2 or 3 iterations on it, there are already a bunch of machines out that are not going to be as good as the machine you will be reviewing. So they will already have shipped those machines and then made fixes, and then you as a reviewer get that machine that is hopefully improved. They've definitely done testing on the early machines.
Yeah, the question now is if the first buyers are beta customers. I don't think so in that case, because
we've had that come up recently, right? What was it? I think it was the same with some other machines, right?
Yeah, well, I just stopped accepting review units that haven't been released yet, or just like we already shipped 5 and here's a review unit, and nothing was working because it's not worth my time. Prusa, I think in their defense, they did quite a lot of testing before they shipped out the first units, and there can always be things that come up. And just the same with Amazon reviews. You usually have just black and white. The white ones are sometimes maybe bought reviews, but if somebody is very upset with his product, he will way more be tempted to leave a review and just put out his anger in some way or another than if he's totally okay with the product. So usually people see more the bad reviews than the good ones, even though just maybe 1% or 1 of 1,000 or 1 of 10,000 have exactly this issue. Well,
if you're moving as many machines as Prusa is, like it's guaranteed that somebody's gonna see issues in one way or another that just have slipped through quality control. Just happens, and it's gonna be very visible, which I hope is gonna get them to at least comment on it, look into it, learn something, improve on it, versus a machine that somebody makes a video, makes a glowing review about it somewhere, and people go out and buy, and I don't know. I don't know.
Maybe
they're moving more machines. There are going to be more issues that are found.
Maybe just to finish that up, I just checked the assembly manual of the Mark III, and the Mark III uses the same style of connection with the cable shoes directly clamped onto the copper pads.
Okay,
so I think pre-tension shouldn't be an issue. Just the problem that the cable shoes were on the wrong side of the PCB was not optimal.
Is there a pad on the bottom?
I don't know.
Exactly.
Well, for the Mark III, there is not. So I assume for the... sorry? No, there is not, because there is... I think I just posted a picture from 3D Maker Noob, and he shows a picture from the lower side, and the lower side doesn't have a tab. So yeah, should be connected to the top, but even in this configuration, should be fine.
It should definitely be on the top.
Yeah.
It's probably either it's assembled wrong, or they figured out something. Oh, if you put it on the top, we can't really assemble things as expected, and it's going to collide into stuff.
Yeah.
Might be a last minute fix. I don't know.
Let's continue.
It's something they should fix. But if they don't, it's not a big deal either. Okay. Stefan, can the lightweight PLA be used as a rubber damper? I have a thing moving fast and I want it to slow down when it hits a wall. That's a question from George.
I would rather use the VarioShore TPU, because it's a TPU which is foamed up, that has, I think, more a rubbery and dampery consistency than the PLA, because the PLA is still a way more rigid material as a TPU. So to answer the question, yes, maybe, but if you have the option, go with the VarioShore TPU.
It's like a styrofoam, I guess, from the way it bounces.
Exactly.
Consistency-wise, yeah. Okay.
In comparison to, for example, a EPP.
Yeah.
Which is just softer.
Yeah, softer, springier. A person without a name is asking, what do you think about using lightweight PLA with lost material casting? Have you worked with lost material casting at all?
I have worked with normal PLA and lost PLA casting, where it burned the PLA out. Could work, could reduce the amount of ash that you're producing, but I think you are also pretty well off if you use just standard PLA without any color on the inside,
additives, modifiers and
stuff like that, or even the specially designed polycast from Polymaker. That is a it's the same material as their Polysmooth, so you can smooth it, but is engineered in a way that it leaves only very little ash in the end.
Right. So I've actually worked with a company who does casting with lost PLA. I've helped them set that up. They now have a stacker and a bunch of Mark IIIs and a BCN 3D, a modified one. What else did they buy recently? They bought one other crazy machine recently where they're like, we need it. We need big stuff. So they're making pump parts, pump bodies, impellers, all that sort of stuff. So for them, PLA, natural PLA from dust filament is exactly what they're using, is working well. They're not doing sand casting. They're doing the high detail stainless casting, where they basically cover the part with a slush coat, few slush coats, ceramic, that then gets dried. Then I think they burn out the PLA, stuff gets fired, etc., etc. A few challenges there are the PLA actually expanding with temperature, and possibly cracking the mold.
Okay.
Because it's a very brittle, essentially, form that you're building. And PLA apparently is at that perfect point where it gets soft before it expands too much and cracks your mold. So you need that low thermal resistance of PLA for this thing to work.
Okay.
I think they've also tried polycast, but like they've already had their process set up for PLA. So PLA for them actually works very well, burns out cleanly, does all that. Now, the lightweight PLA might be a nice option because you have, well, first of all, you have less material, and you also have a less rigid material that you're putting in there. So that entire topic of the part potentially cracking, all of a sudden is gone because you have a soft foam that you're doing instead of a rigid plastic that now wants to expand. Like you brought up the typical styrofoam lost material casting that is done for like engine blocks and stuff. A very similar idea to the lightweight PLA, I think, where it's a soft, low density material.
But I think the density of styrofoam and the foams that are usually used for those applications is even smaller than the one that lightweight PLA has, because lightweight PLA we get to a density of around 40%. I would assume if I put a sheet of styrofoam on a scale and have the same like volume of polystyrol, which is not expanded, we probably only have a density of 5% or even less. So there is way less material to burn out.
But then again, you have infill that you can use for the lightweight PLA. So it does kind of make up for that. Might be an option for the lost material casting, though. Again, regular PLA actually works really well.
Cool.
Interesting one.
Belvi from, I think, Germany is asking, question for the next podcast. Why are there no linear motor driven 3D printers? Resolution is good enough, torque of them is just fine, and they have way fewer moving parts than the standard i3XY design.
And also not having to use belts is a nice idea.
Yeah. What is a linear motor?
What is a linear motor? Okay. Let me take a stepper motor. So stepper motor, you have your rotor on the inside, which is basically a magnet in very simplified terms. And then you have a bunch of coils around that rotor. So those are arranged in a round way. So you have actually not just in a DC brushless motor, you have very few coils. In a stepper motor, typically you have more just to get a bit more resolution, though it varies from the exact motor type. Linear motor, you take this thing, you basically cut open one side and you roll it out flat. So now instead of a rotor, you have a linear element, a magnetic linear element that moves over coils that are energized in series. So you can still do that step where you basically pull your slidey part, what used to be your rotor, you pull it into one position, you change the energization of your coils, it moves an increment, and you can basically move your linear actor with the same logic as a stepper motor essentially, but it has less moving parts. You don't have radial bearings, you have linear bearings, you just integrate it with your linear slides. It can, you lose the belts obviously because you're directly pushing on your axes, and it's a motor type that is very interesting. I think the ICE, not the ICE, the maglev trains. Maglev trains are essentially big linear motors.
Okay. Yeah. Okay.
So same thing, same principle. So linear motors are used in, I think they're used in some consumer goods. I'm not sure where. They're used in proper CNC mills. So Bearbeitungszentrum typically has linear motors on most axes. I don't know. But they use linear motors very often. And yeah, it's just a good fit for that. Why are we not seeing them in 3D printers? Well, because they're not, I mean, we could look up how much they are in AliExpress, but if I go in there right now and I get a stepper motor and a pulley and a belt, and I'm probably going to be paying like $20 per axis for linear motion. You're not going to be paying $20 per axis for a linear motor in the length you need, because remember, it's not you're not reusing the same angle of your motor. You're not reusing the same segment of your motor for whatever length you need. You actually need to extend the length of your motor for your entire axis. It just gets really expensive really quickly, using a lot of copper for the coils, and it's not a commodity item like a stepper motor typically.
All right.
So
I think that answered it.
Would be nice, but it's just too expensive, I think.
Cool.
Yeah, not using the belt would be nice, but.
All right, next question.
From
Ian Jackson.
Which one do you want to do? Ian Jackson. Great podcast. You guys should start splicing an imagery video to spice up the video. But I don't love your faces. I know that would add a fair bit of time to editing these, but I think it would be a nice touch. Yeah, fully agreed, but no, don't want to.
We already put quite a lot of effort in that podcast, and it would just like explode the effort if we would do like a proper edit for a 1.5 hour video. So we would not be able, I think, to get out episodes that regularly. Usually if we talk about something and don't show it directly, we have, well, links in the show notes that you can check out. And also at least 50% of the viewers / listeners are listening to us using a podcast player, and they don't have that benefit. So it would be kind of not sad, unfair to them.
Yeah, it's just what I think when we set out to do a podcast, we kind of decided on what it's supposed to be, and well, at least I remember I pushed hard for it not being a super overdone or over edited, overproduced. I didn't want it to be that much effort to make, because I know if it's something that is a drag to do, and it's I know you're already taking a week, I'm already taking a week to get a podcast episode edited at times. We just wouldn't end up doing these episodes if it's as much work as doing a regular video. I think the time is better invested in doing a regular YouTube video. So yeah, it's just not the premise of this podcast to be a pure video format that is catered to that and makes maximum use of that. It's just a we get to hang out every 2 weeks and talk about stuff that we've learned, and have you guys be part of that.
Yeah. All right. Last question.
last comment. I guess.
Last comment from the Lord of Farts.
Yeah, frequent commenter.
Yeah, we were talking about, or I especially was talking about, the problem that I have a pellet extruder and a filament extruder, but it is hard to get PLA pellets for a reasonable price. The usual sources that I have here in Germany, the PLA pellets sell for almost the same price as filament, which is not economical, because why not then buy directly filament? And also you have the disadvantage that if you're buying pellets, they're not colored, so you only can print translucent parts if you're not also ordering master batch pigments.
And then mixing it up yourself and hoping that comes out consistent in your extruder.
So he put one source of pellets into the description that will also be in the video description. I also found another source that is Rep World. His source sells PLA pellets for 11 pounds per kilogram, including shipping. That is already almost as much or even more than a roll of filament. But
if you just buy 1 kilogram.
If you just buy 1 kilogram. But to be fair, those are colored PLA pellets. So
so they've gone through an extruder already once, and are not just the version, the clean resin mixed with the master batch, but they've already been extruded and mixed thoroughly. So you don't have to worry about your extruder actually mixing it up properly.
Exactly. So yeah, cool.
Reasonable rates, though. I mean, I don't think you're going to get a filament extruder for economical reasons if you want to save on filament.
There are some other reasons why you want to use it, or also The direct pellet extruder is more maybe for special applications. I heard some guys talking about feeding it with MIM feedstock, so metal injection molding feedstock, which is metal pounder bound together with a binder, because the ultrafuse is quite expensive, and BASF is also selling kata mold, for example, that is basically the same material just in pellet form, which is cheaper to buy. Probably not the right material for the pellet extruder that I'm having, because it features a brass, how's it called? Not the auger, the pipe around the screw. And the MIM material is probably abrasive, so you might not be too happy using it for too long of a time, but that could be an application, yeah.
Gonna get a bit of copper into your alloy.
Yeah.
Never hurt anyone.
All right.
Yeah.
I think
very nice.
That's it for today.
Over an hour again. Wow. And I'm out of coffee. Yeah, all dry.
I'm almost out of water out of my how did they say? Flower jar, vase?
Oh yeah, vase. Your vase. Yeah. That could be printed.
It's a pineapple.
Yeah, obviously, but
I usually drink only pina coladas out of it, but
it looks like a vase. I mean, they're right. They're right. All right. Anyways, are we actually going to be able to record another episode before Murph? I was really looking forward to the episode on the way home.
Yeah, me too. Well, we'll see if.
Nah, man, do the right thing.
Yeah. So you're gonna be at the Malta Maker Fair. That's 27 to 29 of 9th of March. Yeah.
It's in 2 weeks.
Maybe
every 2 weeks, something like that.
We'll see.
And then the weekend
maybe in between Malta Maker Fair and Murph. We'll see.
That should work out.
Yeah. Cool.
So
if you guys have questions, put them into the comments here on YouTube, or tweet at us at the Meltzone, or send us an email. And if you want to support us, head over to our Patreon accounts or become YouTube members, or just take a look at the support us links down in the description and on our main channels.
And as always, thank you all for listening and for watching, and we will see you in the next one. Goodbye.
Bye.